All right, everybody. So today we are going to talk about the difference between polar and nonpolar covalent bonds. When you think about polar, you might think about cold, you might think about snow, but instead I want you to think about polar like a magnet. So magnets have a positive and a negative pole, or like the Earth has the north and the south pole. So we are talking about polar and nonpolar bonds, which are types of covalent bonds. So it's important to remember that in covalent bonds, those electrons are shared. So when we talked about ionic versus covalent, we talked about cookies. So if it's ionic, it would be like someone comes and they steal your cookie, versus covalent would be that each person is sharing the cookie. But if you think about it, you probably have some friends that if you were to share a cookie with them, you would share 50-50. But you also have friends that may take 3 bites of the cookie and only give you one. So that difference in sharing is what makes the difference between polar and nonpolar. And it comes down to the property of electronegativity, which in chemistry we shorten to En. And remember that electronegativity is a tendency to pull electrons towards itself. When we talk about our periodic trends, we often refer to fluorine as the tiny bully because fluorine has the highest electronegativity, meaning that it will pull electrons to itself from other atoms. Fluorine is so electronegative that it can actually bond with noble gases because it will force those electrons towards itself. So again, electronegativity is going to be our big player here. And more importantly, it's going to be about the difference in electronegativity. So first, let's talk about polar. So when we talk about polar covalent bonding, we are still sharing, but those electrons are going to be shared unequally. One atom is going to be pulling the electrons a little bit closer to itself versus the other atom. The way that we can determine if a bond is polar is by its difference in electronegativity. So you'll see here that I'm using some kind of shorthand. So delta in math, in science means difference. So the difference in electronegativity, we're going to be doing some subtraction, is going to be between 0.5 and 1.7. And we can get those values for electronegativity on P table. Oftentimes, if you don't have electronegativity available, a shortcut is that these elements, the two elements, are far apart on the periodic table. Now, since we're talking about covalent, we're talking about nonmetals. They are relatively close to one another. However, we can think that they are relatively far apart compared to how close they could be. So to give you an example, we are going to look at the bond between carbon and chlorine. So first, we're going to need their electronegativities, and for that, we can actually go to P table. So I am going to share my screen. So on P table, if I look at carbon and I look over to the left at its properties, for electronegativity, carbon has an electronegativity of 2.55. Then, if I look at chlorine, chlorine has an electronegativity of 3.16. So then to find that difference in electronegativity, I'm going to take the higher electronegativity minus the smaller electronegativity. We're going to grab a calculator. For this, you could also subtract in any order and take the absolute value. But 3.16 minus 2.55 is 0.61. That difference of 0.61 falls between our range, so this is a polar bond. The bond between carbon and chlorine is polar. Another thing to note is that the chlorine is more electronegative. That means that even though they are sharing the electrons, they are pulled just a little bit closer to the chlorine. So what happens is we end up with this partially negative charge. And then on the carbon, because the electrons are just being pulled a little bit further from it, it ends up with a partial positive charge. These positive and negative ends, as we go through chemistry, you'll learn can create some different interactions or intermolecular forces. So now let's look at nonpolar, which is exactly the opposite of polar. So whereas in polar, those electrons are being shared unequally, in nonpolar, they are being shared equally. For nonpolar, the difference in electronegativity is usually going to be less than or equal to 0.4. Another thing to note is that right now our range covers from 0 to 1.7. Anything beyond 1.7 is going to be ionic. And another telltale sign is if it's ionic, it's going to have a metal and a nonmetal. But back to nonpolar, our difference in electronegativity is going to be 0.4. And if we don't have electronegativity, the electron, or sorry, the elements can be the same, such as a hydrogen-hydrogen bond, or they are close on the periodic table. So to give you an example, let's look at the bond between carbon and hydrogen. Now they are relatively far on the periodic table because hydrogen is a bit off to itself, but we are going to take a look at the difference in electronegativity. So if we look, hydrogen has an electronegativity value of 2.20, and carbon has an electronegativity value of 2.55. So now we find the difference. We take the larger number minus the smaller number. 2.55 minus 2.20. We end up with 0.35. Which means since it's less than 0.4, this is a nonpolar bond. And what makes nonpolar bonds unique is that unlike polar, where we have a slightly positive and a slightly negative end, here everything stays relatively neutral. And what we're going to learn as we go through chemistry is that this can cause different interactions, especially as far as dissolving things into solution. All right, that is it for polar versus nonpolar bonds. On your digital worksheet, you are going to be working through this process for different pairs of atoms. You're going to find those electronegativity values on P table, find the difference, tell me if it's polar or nonpolar, and then tell me what is happening with the electrons. Remember, if it is a metal and a nonmetal, it is ionic.